Hey, this is Sam from Shure. In this video tutorial, I'll discuss the usage of zones, a construct in the frequency coordination and inventory views of Wireless Workbench 6. When you're managing equipment in Wireless Workbench, there are a lot of tools to help you get the best frequencies for all your gear. Basically, all the tools in the Frequency Coordination tab are designed for this purpose, to find effective and compatible frequencies for all your systems. In applications where you're coordinating high frequency counts, it can be the case that sometimes your equipment is organized into different geographical ranges. Think, for example, about, let's say, a music festival, where there might be multiple stages within the music festival. On one stage, let's call it stage A, there might be a number of wireless systems there, and then maybe 1,000 feet over to the west or the east, there's another stage, let's call it stage B, and there's different wireless systems there. When wireless systems operate far enough apart from one another, we are able to take advantage of some RF propagation properties and be more aggressive with how we coordinate frequencies for those systems. What I'm speaking about specifically is intermod products. When you've got wireless transmitters and receivers in close proximity to one another, they can create harmonic resonances known as intermodulation products. These products can have negative side effects with occupying spectrum in the place of where other frequencies would ultimately go. Basically, when there are intermod products on the air, you can typically get less compatible frequencies to operate. So the beauty of zones is it lets us organize this gear corresponding to, in this case, those stages, to be more aggressive about finding compatible frequencies for everybody. So I want to demonstrate an example, and to get us started, I've loaded 52 frequencies into just this default zone. These are all 52 frequencies I'm going to be using for the entire music festival, but I've loaded them into one zone to show you how the calculator can handle this particular coordination when we do not use zones. So before there are zones, all my equipment is just in one place, in one zone. And if I press calculate, you'll notice I found about 35 out of 52 frequencies. And obviously I'm going to need to use 52 frequencies for this particular production, so that's not going to do. What I've done ahead of time is I've created other zones. That's what these tabs correspond to in the coordination workspace. Each one is a zone. The way I created them was I went to Tools, Manage Zones, and then I added a couple here, and you can name them whatever you'd like, but we'll just use the two I created. And I named them corresponding to each of these different venues, or stages in this case, for my particular production. Now, the way that I actually use these zones is I assign frequencies or groups of frequencies to be within one of these zones, and then I run the coordination again. And when I do that, what the calculator will do is assume that any intermodulation products between frequencies in different zones, they can all be ignored. So if I've got a frequency in stage A and a frequency in stage B, the calculator will assume that those two frequencies are far enough away from one another that they will not create intermod products with one another. So let me show you how this works. I know that my Telex BTRs, as well as one of the G10 band of my P10s and my H4 UHFRs, those are all going to be in stage A, so I'll select those headers and I'll right click on them and say move to zone stage A, and boop, there they go. And the remaining frequencies, I'm going to move to the stage B zone. And this is just really for organizational purposes. I could leave them in the default zone as well. Default is also a zone, but for organizational purposes, I want my frequencies to make sense and be allocated in the zones I created. So I'll select those headers, right click and say move to zone stage B. Now you'll notice in stage A, I've got the 24 frequencies that are going to be on that stage, and stage B has the 28 frequencies that'll be on that stage. Let me collapse these just so they're easier to see. So now, if I go ahead and calculate again, whereas before I could only find 35 frequencies, now I find 52 in a flash. How did this happen? Basically, all of the intermod products that we were assuming would be created between all of the 52 total frequencies, a bunch of them got removed when we designated the corresponding frequencies to the stage A and stage B zones that I created earlier. So zones is a great way, if the atmosphere is appropriate for you, to organize your equipment as it is dispersed geographically. Now you might ask, well, how far do these locations, these zones, need to be far apart from one another to consider them zones? It's less really about physical distance and more about RF propagation. In general, we recommend at least 300 feet between the locations, but it could be more if you've got a wide open space where RF can propagate really well, and it could be less if there are metal walls or other obstructions that would limit the propagation of RF between zones. So I think we'll close the tutorial there. I hope it was helpful. If you like it, give it a thumbs up. And if you've got any questions or comments, or if you'd like to see different sorts of tutorials in the future, be sure to let us know in the comments below. Thanks.